So hello everyone. So today we're gonna open starting for 5.1, the new chapter for integral. So this chapter talk about integral is the backward of derivatives. Okay, so we learn how to do derivatives. Today we're gonna learn how to do the backward of derivatives. What's the chapter is in the test on? It's chapter 4, only 4. Yes, only 4. Correct. Only 4. Okay, so 5.1. Let's talk about the area and distance problems and distance problems. Okay, so we're gonna start talk about the area problems. So for example, if I ask you a question like this, find, for example, find the area under the curve this one. For example, something like that. You start from this point, went up like this, up this. So this point is called, for example, A, and this point is called, for example, B. Okay, and here is the function. The function is starting from this point up to this point. This is the curve of the function. This is y equal f of x. So if I ask you find the area under this curve starting from the point A up to the point B, I mean find this area under this curve. Use this correctly. I mean find the area here under the curve, this area. Okay, so how we can find the area? There is like different ways to find the area. So you can like divide this interval. I have actually interval, right? So the function f of x, the function f of x here, the function f of x is defined on the interval, close interval a to b, right? So the best things here to find the area under this curve is to divide, the best things is to divide this area actually into like small areas. For example, I can divide it to the rectangle, for example. Here's the rectangles. I can divide it into rectangles like this, and then find the area of the rectangles, right? So the approximate area of these things is the same as the area under the curve, correct? So this is one of the ways to find the area. Or there is another different ways to find the area. For example, if I want to divide it to the, for example, triangles, for example, small triangles like this, for example, or for this, like for this, or for like small, small triangles, up to finding like small like this, doesn't matter how is you can like make a small rectangles and find the area. But the best idea here to find the area is by using what? Rectangle, not the triangle. Triangle is too much high, too much like hard to find the area. So the best things here to use the rectangles. So if I want to divide this area to the rectangles like that, these are rectangles. This is the first one. This is the second one. This is the third one. And dot, 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 up to here. Also this one means the dot means like another rectangles, okay? Like this. Okay. Here is the rectangle, here's the second, here is the other one, here is another one, and here is another rectangles, another one here, another one here, and here. Okay, what do you know about the area of rectangles? If I have rectangle like this, what's the area for the rectangles? What's the formula for the area of the rectangles? What's the formula for the
Length times
area?
width.
Again, what is it?
Length times width.
Exactly. Width times height. Height, this is the height, for example, and this is the width. So if I call like this is like rectangle, if I call this one as, if I said like, I say like the height is, I call it by W, and I call the width as I. So the area here, so the area of this rectangle is W times I. Okay, W times I. So for this one, if I go back to the example before, here is the rectangles, all the rectangles here, they have the same width, the same width, same width. So the width here, I can call it delta X, the same width, all of them. So this one is the same as this one, the same as this one, same as this one, and all of them. So here for the first example here, I can like call this one. So for the rectangle, that divide the area of the function under the function y equal f of x have the same width. I will call it delta x. So here delta x, I can define it, delta x, I can define it as the last point is b minus the first point over n. For example, if I need like to divide the shape up to 8 rectangles, I can say it like b, the first, like the last endpoints, minus the first endpoints over n, for example, over 8. If I want to like divide the shape up to 8 rectangles. If I needed to divide it up to 4 rectangles, for example, I divide it by 4. If I want to divide it by 3 rectangles, I divide it by 3. Like it depends how many rectangles you want to divide the shape under the curve, or how many rectangle you need under the curve, for example. Makes sense? So delta x, I can define it as the width is the same as delta x is the same as b minus a over n. Okay, now what's the height? What is the height? What is the height? So for each, for example, here is the height. For each rectangle, you see, for each rectangle, they have different heights. This height is different about this one. This height here for the third rectangle is different about the first one and second one. So I can define the heights as the f of the end of the right hand end point. So I can define it for the first rectangle. This is number 1, this is number 2, this is number 4, 4, 5, whatever. So the height for the first one is the same as this point. It's called f of this point, x1 or x0 or x, doesn't matter. So for the second rectangle, here is the second rectangle, I can define the height as this point, f of this point. This point, I call it like fx1. So this point will be like f of x1. For the third rectangle, the height is f of x2. x3 doesn't matter, okay? So for this one, I can define this rectangle as number 1, number 2, number 3, number 4, number 5, and so on. So the height for the first one is the same as this point is f of this point. I call it x1. This point I call it x2, x1. For the second one here, the height for the end f of x2. Okay, so the height I can define it as f of xi. Okay, as f of xi, doesn't matter what is I. Okay, now I'm gonna give you an example to show you how we can use these things. Now, after that, before like we finish, the area is the same as the sum of the area of rectangles is the same as sum, I got like this, f of xi times delta x from I equal, for example, 0 up to n. Area under the curve, So I define the width, the height, the area under the curve. Any question before we go over the example? Makes sense? Okay, I'm gonna give you an example for this. Here's an example. Find use the rectangle. To estimate the area under the parabola y equal x square from 0 to 1. Okay. So do you know how to graph the parabola? Of course, most of you, I'm sure, like they know how to graph the parabola x square. Here's the x square. Here is the parabola of x square. But they ask to find the area from 0 to 1. They're not asking for all the points. They ask only starting from 0 to 1. So here is the point 0. And here is the point 1. I'm going to call the point 1 as here. So actually, here I'm going to like fix it, make it like more parabola. We're going to look like that. This one. Okay. So they ask for the area starting from 0 up to 1 under the curve. Here's the 1. So what does that mean? The other side, we don't need it. This side, we don't need this side. So how we can find the area? By what? Using the rectangle. So again, like using rectangles to find the area here. I use the rectangle to find the area here under this curve. Okay. Okay. So I'm gonna divide it up to 4 rectangles, 4 strips. Okay. I'm gonna divide it. I'm gonna like use only for this example 4 strips. Okay. So I'm gonna divide it up to 4 strips. So what is delta x here? How can I divide the delta x? What is delta x? The width is the first point. What is it? What is B? Here's the formula. What is B?
It's 1.
1 minus, what is the first
0.
point? Okay, over what? And what is N here? I need 4 rectangles. What is N? Will be 4. Okay. So N here should be to be like 4. Exactly. So I can
I have a
say
question.
here. Yeah, go ahead.
How do you know how many rectangle we're gonna use?
Like the question they give you, how many strips you can use.
Oh, okay.
It depends on the question. Yeah. So if I told you like use 4 strips or 4 rectangle, you're gonna use N as 4. Okay. So
Okay.
here is 1 minus 0 over 4. 1 minus 0 over 4 will be like 1 over 4. So I can say the width for each rectangle is 1 over 4. So first of all, I'm gonna like graph a line like this. This line has like, I said like N equal 4. I choose N equal 4. And N equal 4 means we have like 4 lines. So we have, like 3 lines. So here is number 1. Here's the first subinterval, 1. And 2. Here's the second 2. And here's the 3. And here's 4. So I have 4 rectangles. Here's the first rectangle. This is the first one. Second one. Fourth one. I need this one. So now if I ask myself, here's the rectangles, right? You see the rectangles? If I ask myself if I need the height to be the right end point, so the shape of the rectangles, it should be like this. If I need the height, so all of them, they have the same width, right? So this is the same as delta x, delta x, delta x, all of them, they have the same delta x, correct? All of them, they have the same delta x. So I can divide here 0, 1. Here's delta x. The first one is 1 over 4. Add another 1 over 4 is what? 1. Like 2 over 4. Add another 1 over 4 to that 2 over 4 will be what? 3 over 4. Add another 1 over 4 to the 3 over 4 will be what? 4 over 4 is the same as 1. So here's like, I get like 4 sub-intervals. Here's the first one. Here's the second one. Here's the third one. And this is the fourth one. 4 sub-intervals, or 4 strips, or 4 rectangles, doesn't matter. Okay, now the height is different. Like sometimes I need the height to be, like I said, I can like choose the height would be like f of xi, correct? So here I can say the height is the same as f of xi. So this is this point here, I can call it x1. This point is x2. This point is x3. And this point is x4. And this point here is called x0. Okay? Now, like to find the area, like there is different ways. If I need it like by using I can use the rectangles to be like under the curve or above the curve. Make sense? Like there is 2 estimates to find the area, like upper estimate or lower estimate. Like for that upper estimate, if I need like the rectangle to be above like the end points here, this is the end point for the first, here's first subinterval, second subinterval, third subinterval, the fourth subinterval. So if the end point here for the first one, I need it to be like to the right, so I can graph the curve as distance. Here's the first, like if I need it like, I'm gonna start for the left. So if I need it to the left, so here is the first rectangle. Here's the second rectangle. There's the third rectangle. And here's the fourth rectangle. So this is the first area. Second area. I need to find the second area. The third area. Fourth area. So by finding the area for each of these things here, Here's number 1, I call number 1, number 2, number 3, 4. If I find the area for each of them, 1, 2, 3, 4, I can find estimate of the area under the curve, correct? The estimate of the area under the curve. I'm gonna use the white color. Here's number 1, number 2, number 3, number 4. Okay, so I'm gonna find the area for this rectangle. Here, the area. I'm call it R4. R means R. I choose the number like the letter R here means the upper estimate. Upper estimate means look for each of the rectangles. They have upper above of the curve, correct? Look above the curve means like the estimate here above our upper of the correct area. So I mean like the original area here, the original area will be like less than the estimate, Why? Because the estimate, if you see here, like they have like more area, we can like add it to the original area. I mean like here I use R4 means the upper area will be like the same as delta xi times, I mean like the sum. I don't have to forget the sum is the same as the sum of delta xi times f of xi. By the way, delta xi is the same for all of them, correct? So here I can choose xi without delta xi. Here I can use delta x because for all of them, they have the same delta x. Or if you don't believe me, or you don't like this using this notification, you can like say, like this is f of x1, f of x1 times delta x for the first rectangle. This is the first rectangle. The area of the first rectangle is the same as f of x1 times delta x plus the sum of the second rectangle. Here is the second rectangle is f of x2 times delta x plus f of x3 times delta x plus f of x4 times delta x. Or if you want to use it as a sum notation, here is the sum notation is f of xi times delta x from I equal 1 up to 4. Make sense? Any questions so far? Is it clear what I said before? Okay. Now I'm going to find the area. So what is delta x? As I said before, here is delta x. This is delta x. I can use it all the time. Delta x is 1 over 4 for all of them. F of x1 is different from point to point, correct? So f of x1 is the same as f of what? Is it the same as 1 over 4? Why? Because here is the graph of the line. This is x1, this is x2, this is x3, this is x4, and this is x0. So f of x1 is the same as f of 1 over 4 by using this things. This is f of 1 over 4, f of 2 over 4, f of 3 over 4, f of 4 over 4 is the same as this point. Again, x1 is the same as this point. x2 is the same as this point. x3 is the same as this point, and x4 is the same as this point. I'm going to graph a small line like this to show you exactly what I did here. Okay, f of x1 is the same as f of 1 over 4. What's the function actually? The function is what? Here's the function. Y equal the function is f of x is f of x equal x squared. So what is 1 over 4 square? Is 1 over 16. Correct? Now, f of x2 is the same as f of 2 over 4. 2 over 4 is the same as f of 1/2, correct? Plug the 1/2 inside the function, what do you get? So this function, I mean,
1/4.
1/4, 1/4. Now with the same things for f of 3 x3 is the same as f of 3/4 is the same as 9/16. And the last point I think is f of x4 is the same as f of 4/4 is the same as f of 1 is the same as 1 square is 1. Okay, plug the values inside the function. What do you get? Here, by the way, delta x is a constant. I can take it outside, and the sum of the function f of xi, I equal 1, I mean 0. I can start from 0 because it doesn't matter to the 4. So, okay, plug now, we have to find the area. It's called upper estimate for the area R4 by using this formula. Okay, plug the values. What do you get? What is R4? Is delta x times the sum of xi from x equal 0 to n to 4. And here is 4. So it will be like, what's delta x? What is delta x again? Is 1/4. This is constant. This is the weight for all of them. Okay? Kenneth, he said 1/15/16. Let's see. We're gonna see. So delta x here is 1/4. The sum of these things here, the sum of this, it will be like 1/16. Again, 1/4 times 1/16 plus 1/4 plus 9/16 plus 1. And the answer is what? The answer, if you want to use the calculator, is going to be like 0.468. Okay. By the way, this is estimate of the area. So what's the correct area here? This is estimate. Is upper estimate, actually. It's not just estimate, it's upper estimate. So what is the correct area? Is under of this. Is below of this. So the area under the curve is smaller than this value. Smaller than this value. So here I can say the area. Why is smaller? Why is smaller? Because if you see here, we have we're taking extra area. You see this small triangles? So all of this, they give more values for the area. That's why I can say here now, the area is smaller than 0.468. Make sense? So the area is smaller than 0.468. Any questions so far? So far, we find the area by using the function of the right endpoints. We use the function of the right endpoints. I find the value of the right endpoint at this point, at this point, at this point, at this point, the right endpoints of each interval. So actually, each interval here, if I want to make it a sub-interval, the interval here I have is from 0 up to 1. The sub-interval it was from 0 to 1/4. This is the first one. The second one from 1/4 up to 1/2. The third one, it was from 1/2 up to 3/4. And the last one was from 3/4 up to 1 or 4/4 is the same as 1. So actually I have 4 subintervals. Here's the first one, second one, third one, fourth one. For each of them, I take the high as the right end point. It was the first interval, the high was f of 1/4. The second interval, the high was f of 1/2. The third interval, the high was f of 3/4. The fourth interval, the high was f of 1. But now I want to find the area of lower estimate. Lower estimate means I'm gonna like find the area when the endpoint is the left endpoint. I'm gonna find the area when the high is the same as the value of the left endpoint. So the area when f of 0, f of 1/4, f of 1/2, and f of 3/4. Make sense? So before look here before we start like finding the rectangle when the area we find the rectangles such that the high was the right endpoint. It was here, here, here for this one. For the number 4, it was 1. For number 3, it was this point. For number 2, it was this point. For number 1, it was this point. Now we're gonna do the opposite. For the first one will be like this point. So this point and this point and this point. It's called the lower estimate. Okay, so I'm gonna do it very quick. So I'm gonna take the copy of these things here, duplicated. Here, find the lower estimate of the area. So the lower estimate, actually, like I said before, we have intervals. Here's the same intervals. I use this interval, subinterval, I'm sorry. So here's the subinterval. Now we're gonna use different high. The high will be like completely different, not like this. Okay. Okay. Here is the function, and here is we divide it into subintervals. I'm gonna remove these things here. Okay, so for the first one, here's my first, this is, by the way, this is 1, this is 0. Here is 0. Again, I'm gonna divide it up to 4 strips. So dividing up to 4 substrips, delta x will be like the same as b minus a over n. B here is 1, and a is 0 over 4. Will be like the same things as before, is 1/4. So delta x, the width for each strip is 1/4. Now the endpoint is the left endpoint. So this is the first interval. Okay, I'm gonna divide it to the intervals like this. This is 0 up to 1. Here's 1/2 or 2/4. Here's 1/4. Here's 3/4. Again, this is the first, this is one of the subintervals. It is another subintervals. Here is another one. And here is another subintervals. Okay. So the first, here is I'm gonna like rewrite it. So the interval here from 0 to 1/4 is the interval 1/4 to 1/2 to 2/4, doesn't matter. Here is from 2/4 to 3/4 and 3/4 up to 1. Now we're gonna use like the end points, the left endpoints. This is my height. This is my height. So if I want like a graph exactly what's happened, here is the first point. It would be like, this is the first rectangle, our first shape. Here's the second point. Go up. This is, here's the, be like the same like this. This point is same like this. So let me clean it to show you exactly what I did. Okay. Okay. Here's 1/1. Here is 0. So this is the first. Here is the, can divide it to. This is the first point. 3. Here's 1, 2, 3. This is 1/4. 2/4. 3/4. Okay. Starting at this point, this is 0. This is the first step. At this point, this is the second step. Okay. At this point, here's the third one. At this point, it will be like this. So the graph would be like, the area would be like the same like this. We're gonna take the area for this one, the area of this one, the area of this one. And the area here is what? Under this line is what? What is the area under this line? What's the area under this line? Is 0. Okay. So here is the first rectangle. Here's the first rectangle, is the line. This is the second one. This is the third one. This is the fourth one. Now I'm gonna find the area of this rectangles. I wanna find the area of this rectangles. So I call this one again 1, here's 2, here's 3, here's 4. Look at the difference between this one and the other one. Here's the other one. The rectangles, it's up. We're using here the right endpoints. Up to this point, the right. Up to this point, I mean, like I use the like the right endpoints. Up to this one, I use this one. At this one, I use this one. At this one, I use this one. I use this one, I use this one. Like this. But here, the difference, at this point, I use this one. At this point, I use the second, like the second side. This one, like use this one. At this point, I use this one. I mean, for the second one, for this one, I use the left endpoints. So here's the left endpoints: the 0, the 1/4, the 3/4, the 2/4, and the 3/4. So I'm gonna use that to find the. I'm gonna use the same formula like before to find the area. So the area under the curve is the same as delta x times the sum of f of xi. I starting from 0 to up to n. Okay, what is delta x? Again, is 1/4 times f. What is f of xi? Is would be like f of 0 plus f of 1/4 plus f of 2/4 plus f of 3/4. 1/4 times, what is f of 0? Plug this value inside the function. What is f of 0? Here's my function, f of x equal x squared. What is f of 0? 0. What is f of 1/4? 1 over? No.
16.
16, exactly. What is f of 2/4? Is what? 1/4. Because 2/4 is the same as 1/2, and 1/2 squared is 1/4. Plus, what is the f of 3/4? 9/16. 16, yes, correct. Now, the answer for this one, if you want to use the calculator, you're going to get 0.2186 0.875. Okay, so the area by using, I'm gonna call this one as L4. L4 means the lower estimate. And I'm gonna call this one as R4. R4 means the upper estimate. Upper estimate is lower estimate. So actually I can say now the area is between lower estimate, L4, and between upper estimate, R4. Makes sense? So I can say now, after all this calculation, A is between 0.21875, this value, and this value, 0.468. 0.468. So here is the area. So I find the area by using the rectangle. I divide the area up to like the area under the curve as a rectangle. I find the rectangle like the upper estimate, lower estimate. Then I put the area is between the lower estimate and the upper estimate. Makes sense what I did for this example? If it's not clear, I can explain it again. Is it clear? Okay. If it is not make sense, I can explain it again. Okay. So in this question, I use n equal 4. What does that mean, n equal 4? Means I use 4 strips or 4 rectangles. What about if I use like rectangles, like 10 rectangles or 20 rectangles? What's gonna happen here for the area? Close to the answer, correct. Will be like close to the answer, more accurate. The area will be like more accurate if I use n equal, like n is larger and larger. So when n goes to infinity, for example, they give me exactly the area. What's the value of the area? Make sense? So here is n, I use it as n equal 4. If I use n is larger and larger, I'm sure I'm gonna get like accurate answer. So I'm gonna give you like a table, small table, to show you exactly what happened when n is large and large. So if n equal, for example, 10, this is like using the computer for estimate, like the lower estimate, ln, for 10 will be like 0.285. And the upper estimate for this one will be like 0.385. So look, the area here will be like between 0.385 and 0.285. It's more accurate than these things when n equal 4. Look, like we're getting closer and closer to the correct area when n is become large and large. If I go like more than 10, if for example, if I go like to the 50, so L of 50, it will be like 0.32340, and R of 50 will be like 0.343 and 400. And the area will be like more accurate and accurate for n equal 50. Will be like between 0.34 and 0.323. If I choose here now n equal 100, or like 1,000, for example, 1,000, look, L of n is going to be like 0.3328, and the upper estimate will be like 0.3338, and the area will be like more accurate and accurate, like I said before, 0.338 and 0.3328. Now I can like taking the average, if I want to find the correct exact area is the same as the average of distance of when, like here I can say it, when n equal 1000 will be the same as 0.3338 plus 0.3328 divided by 2 is the same as 0.33335. This is estimate here, it's not equal, estimate. So I can say now the area, the estimate of the area when n is large is 0.333. Like this. Make sense? How about the midpoint? We're gonna talk about the midpoint, not now. But so far so good, right? So we're gonna use, like when you use n is large and large, you're gonna get accurate answer. Any question? Okay, now let me give you another example. Example like this. For the same region of the previous example, or like example one, I'm gonna call it example one, show you exactly which example. Example one. Here I call it this one as example one. Okay, the question is, show that the approximating sum, it's called R of n, approach 1/3. So they asked, like they said, it's like here, if you wanna like repeat what the question asked, they said, show that like Rn after like when n goes to infinity is the answer is 1/3. Wanna like rewrite it in different way, show that the limit for Rn when n goes to infinity, give me 1/3. Any idea before we start like solving this question? How we can show these things? The limit of Rn when n goes to infinity equal 1/3. Who can like give me any how we can start like solving something like that? First of all, I need like to give me like what is R of n. I don't here. I'm not going to give you n is equal 4 or equal 5 or equal 10. I'm not giving you like a certain points for n. I just say n, like any random points, any integer points. What is R of n here? If I want to find R of n, it's the same as the area, the upper area, the sum of the upper rectangle, rectangles, the upper, like the sum of the upper rectangles. Okay, like how we can find the upper rectangles? What's the area of the upper rectangles? Like I said before, what's the formula? Delta x times what? F of x I. And here we have sum, because it's the sum actually. When I equal 0, for example, up to n. Make sense? Okay, my question here, what is delta x? If I want to find delta x for n, not for like, yeah, again, I'm not giving you like n values. I'm not giving you a values. I'm not saying n equal 4 or 5 or like whatever. Just I ask, what is delta x? What is delta x here? It's the end point minus the first point over n. What is the end point? What is the interval for f of x for the previous one? I said f of x equal
1.
x squared from 0 to 1. Like, what is the end point?
It's 1.
Is 1. Minus, what is the first point?
0.
Over n. So what is delta x? 1 over n. Delta x is 1 over n, because n here is like any random points, integer points. Not equal 0, I mean like natural points, natural. Like start from 1 to infinity. I'm not saying like this is like any n, natural number. Okay, here is delta x. Now, what is f of xi? What is f of xi? So if like here is like for finding f of xi, because this is like I said, f of xi is the same as f of the right end point of each sub interval. Make sense? Is the right end point of each sub interval. So for example, if I have like sub interval like this, here's my interval. Here's my interval, a line like this. This point start from 0 up to 1. And I want to divide these things as subintervals, some points. Make sense? So as I said, the point here, the first point, it should be like 1 over n. This point is 0. This point is 1 over n. Why? Because here, if I want to divide these values here, all of them, they have delta x, the same length, delta x. Okay? So the first length, starting from 0 to this point, this is 1 over n. This is delta x. Now the second point, this point, it should be like this interval, delta x plus delta x. Delta x is 1 over n plus 1 over n. What is 1 over n plus 1 over n? 2 over n. Again, this interval here, the distance from 0 to this point is delta x. Delta x is 1 over n. So actually this point is 1 over n. This point here. This point is 1 over n. Now the second point here, it should be like 1 over n, the distance from here, plus the distance from here is the same as delta x plus delta x. Delta x plus delta x is the same as 1 over n plus 1 over n. And this is equal what? 2 over n at this interval. Okay, the third one, this point is what? What is this point? 3 over n, correct, 3 over n. And if I keep like moving, this point, the new one, is the same as what? 4 over n. Make sense? So I keep like like giving a point up to arriving to this point. This point is the same as n over n. N over n is the same as 1. And this point here is the same as 0 over n. 0 over n is the same as 0. Okay. Now, r of n, like this one, r sub n, like I said before, is the same as the upper estimate. Upper estimate means the right end point of each subinterval. So I have subintervals. Here's the subinterval. Subinterval. The subinterval starting from 0, 1 over n. This is the first subinterval. Second one, 1 over n to 2 over n. This is the second one. Third one, 2 over n up to 3 over n. And so on. Up to where? Up to n over n here. And here is n minus 1 over n. And this is the same as 1. Okay? Now my question is finding the height. So this is the width. This is the width, correct? Now the height is the same as f of the right end point. So it's the same as f of 1 over n. What is f of 1 over n? Plug it inside the f of x equal x squared. What is the value?
1 over n squared.
Exactly, 1 over n squared. And the same things here. F of 2 over n is the same as what?
4 over
2
n
over
squared.
n squared, correct. Here, square. Okay, what is this one? F of 3 over n is the 3 over n squared, and so on for all the values. So now I'm going to back again to the r of n. What is r of n? Is the same as delta x times the sum of f of xi from I equal 0 up to n. And this is the same as, what is delta x? Is 1 over n times the sum of 1 over n square. I'm not going to say it like this. I'm gonna like say it like that. Here. I'm not going to say it like the notation. It would be like 1 over n square plus 2 over n square plus 3 over n square plus dot 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 up to n over n square. Makes sense up to now? Everything is clear? I just using the formula. R of n is the same as the width times the height. What is my width? Is this thing. What is the height? This thing. This is the width, is fixed for all values, 1 over n. How I find it? Here's the formula. B minus the formula, delta x equal b minus a over n. N is any random values. I'm going to simplify it now. I'm going to simplify r of n to show you. Then I'm going to take the limit for n of r of n to show you the limit when n goes to infinity equal 1 over 2. This value. Okay, I'm going to do it step by step to show you exactly. Here is r of n equal 1 over n. 1 square is 1 over n square plus 2 square over n square plus 3 square over n square plus dot 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 n square over n square. Okay, so I can now factoring what I can factor 1 over n square. Do you see these things? I can factor it. So what's the answer? 1 over n times 1 over n square times 1 square plus 2 square plus 3 square plus n square, like this. Okay, what does that equal? If you want to simplify it, 1 over n to the power 3, 1 square plus 2 square plus 3 square plus n square. Okay. I don't know if some of you say like did say, like did see the formula of something like that in sequence before in high school or in college, or I don't know. Did you know the formula of sequence like that? Or did you see the formula of sequence like that before? Have you seen something like that before? Or do you know the formula of sequence when the numbers like the sum? No? Okay. So I'm gonna give you the formula here. The formula said if I have something like that, 1 square plus 2 square plus 3 square plus dot 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 plus n square, this is equal, the first number is n times n plus 1 times the odd numbers 2n plus 1. Again, n times the following number, n plus 1, times the odd numbers 2n plus 1 over what? Over 6. This is the formula. So I'm gonna like substitute instead of these things, this formula. Make sense? I'm gonna use
Wait,
this
can you
formula.
repeat?
Okay, I'm gonna repeat. These things here, this is a sequence. We don't talk about sequence in this class or like in this course, but I don't know if you see something like that. The formula said if I have something like that, the formula, the sequence, the sum of this sequence is the same as these things. What do you mean? Like if I, for example, like I told you, find the sum of something like that. 1 square plus 2 square plus 3 square plus 4 square. What is the sum? Use the formula. What's the formula said? Use the n. What is n here? What is n? Is the last number. What's the n? It's 4. Times n plus 1. What is n plus 1? The next number of 4. What is it? It's 5. Times 2n plus 1. 2 times 4 plus 1. What is 2 times 4? 8. 8 plus 1 is 9 over 6. So the sum, instead of like doing calculation and finding the sum of something like that, you can use the formula here to find this one. So what is 4 times 5? 20. 20 times 9. What is 20 times 9? 180. 180 over 6 is what? 30. So the answer is 30 for this sequence. Make sense? Is it clear? Okay. So the same things here. The formula of this sequence is the same as these things. I'm gonna like plug this sequence instead of this one back. So R of n is 1 over n to the power 3 times n plus 1 times 2n plus 1 over 6. Okay, I'm gonna simplify it. Here I can like take 1 n with this n, I can cancel it out. Can cancel out the n with the power, can square. So I'm gonna get like n plus 1 to n plus 1 over 6n squared. Okay, I'm gonna simplify it more. Would be what? 2n squared plus 2n plus n plus 1 over 6n squared, and this is equal 2n squared plus 3n plus 1 over 6n squared. Make sense? Now detect the limit. Limit for r of n when n goes to infinity is the same as the limit of 2n squared plus 3n plus 1 over 6n squared when n goes to infinity. What is the value of the limit? This is review. What is the value of the limit? What's the value of this limit? Is 2 over 6. Why? Why Freddy is 2 over 6? This is correct. 2 over 6. The answer is correct. The highest exponent, correct. We're taking the coefficient because going to infinity, when you see something like that, you don't have to plug inside the infinity. No. Because the numerator and the denominator, they have the same power. What is the power here? What's the highest power here? It's 2. What is the highest power here? It's 2. You take the coefficient of the highest power over the coefficient of the highest power. It will be like 2 over 6. And this is equal. And this is done. Why is this done? Because look, what's the answer asking about? The question asking about the proof. Proof that the limit when Rn, when n goes to infinity, equal 1 over 3. And this is what we did here. It's 1 over 3. The limit for Rn, when n goes to infinity, they give me answer 1 over 3. Done. Okay? Any question?
Is there a reason why we put 6 in the denominator?
Why the reason we put 6 here? You ask about where? This formula?
Yeah, in the formula.
The formula is 6. I'm not going to prove it actually, because this is the formula. The formula is fixed. The formula is fixed. I'm not going to prove why it's giving 6. But you have to use, you should to know how to use it inside this example. I have to plug this value inside here. I'm not going to explain why 6 because it takes a long time. But you should to know this is the formula for these things, is these things. And you have to plug this one inside instead of 1 square, 2 square, 3 square to the n square. Makes sense? Does it make sense?
Yeah.
Perfect. So we prove that the limit for Rn when n goes to infinity, they give me 1 over 3. This is what we need for this example. Okay. Now, sometimes we don't need to take the right endpoint or the left endpoint of the subinterval. Sometimes we need to take the midpoint inside the subinterval. Make sense? So here is my subintervals. This is my subintervals here. What is the subintervals? Like this one. This is my subintervals. Sometimes I don't need to take the left endpoints, like this point. Or sometimes I don't like to take the right endpoints, this point. Sometimes I would like to take the points inside the interval, inside here, midpoints. The midpoints is called the sample points in this section. The midpoints inside the subinterval is called the sample points. Is a point inside the subinterval to find the area. Make sense? Okay. So I'm gonna before talk about the sample points, I'm gonna give you definition of these things for what we talk about, definition. The area. A, call it A, of any region, of the region. Call it S, this region. That lies under the graph f of x is the limit of Rn when n goes to infinity. Is the same as what? Limit of delta x, open parentheses, f of x1 plus f of x2 plus dot 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 plus f of xn when n goes to infinity. This is a very important definition. The area is the same as the limit when n goes to infinity for R of n. R of n is the upper estimate. Or if you don't like to use the R of n, is the same as lower estimate or the area is the same as the limit for L of n when n goes to infinity. L of n is the lower estimate using the left endpoints. Using the left endpoints. Using left endpoints. Okay, so what is the formula for this one again? Is the same as here again, like this is the same as delta x f of x0 plus f of x1 plus dot 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 to f of x n minus 1, not to the xn. This is the area. So actually we have two formula to find the area by using the limit when n goes to infinity. Okay, by the way, I did a small mistake. Here's the limit when n goes to infinity. Okay. Makes sense. Okay. Now, if I have something like that, like I said before, I'm not going to use. I'm gonna go using sample points, like I said, sample points. Here, I'm gonna like define the sample points before. Sample points is a point defined by like something like that, x1 star, x2 star, x3 star, and so on, like this, up to xn star in the subintervals of inside the subinterval of the subintervals. For example, like I explained before, like here's the, for example, x0 up to x1. Here's subinterval. Here's the subinterval x1 to x2, x3 up to x4, and up to xn minus 1 to xn. So for each subinterval, we have sample point. It's called, for the first one is called x1 star. For the second one is x2 star. For the third point is x3 stars. And here for xn stars. And if I want to define the area by using the subinterval, the area by using sample point, I can define it as area equal limit when n goes to infinity, delta x, but here's the function is different. It will be like f of x1 star plus f of x2 stars plus f of x3 stars plus f of xn stars. Okay, makes sense? Like it depends on how you going to find the area. Like it like difference. Like if you want to use the left endpoint of the subinterval, right endpoint of the subinterval, or like the midpoint of the subinterval. So I'm gonna give you like the last example in this section, like a very quick example. Then I'm gonna move to the next section. By the way, the distance problems, we're not going to talk about the distance problem for this section because it's not in the it's not in the syllabus. Okay, it's not would be like in the syllabus. So, but here we have to know the area because the area is the key to understand the next section, and the third section is talk about the integrals. Integrals is the backward of the derivative. Okay, so I'm going to give you an example very quick. We're going to do this example very quick, then we're going to move to the new section is 5.2. So the example is talk about let A be the area of the region that lies under the graph of the function f of x equal e to the minus x between x equals 0 and x equal 2. Let A be. Okay, my question is, number one, using the right endpoint, find an expression for the area A as limit. By the way, we don't need to evaluate the limit here. I don't need to evaluate the limit. Number two, estimate the area by taking the sample, by taking the sample point to be midpoint. What does that mean? The sample point is not all the time midpoint. Sometimes sample point, any point inside the interval. Makes sense? But in this question, they said, use the sample point as the midpoint, okay? Do you know the formula for the midpoint? If I give you like interval and ask you what's the midpoint, can you give me the formula for the midpoint? What's the formula for the midpoint? I need the formula for the midpoint. Okay, the formula for the midpoint, for example, if I give you like here, the midpoint, midpoint, here is like the interval A and here is B. The midpoint of this interval is A plus B over what? Over 2. Correct. The midpoint is A over B, A plus B over 2. So using the right, like, let me start for the first one. Any idea how we can using the starting for the first one? Any idea? Let A be the area of the region that lies under the graph of f of x equal e to the minus x between x equals 0 and x equals 2. Using right endpoint, find an expression for A as a limit. I need to find the limit. I need to find the area as a limit. By the way, using the right endpoint means what? The limit of what? Of Ln or Rn? Here in the beginning one, they said using the right endpoints. Right endpoints is Rn of, yes, Rn. R means right. Rn means right. Ln means left. Left endpoint. Make sense? So we're gonna use the right endpoint. Limit when n goes to where? To infinity. So what is the formula for this? What is the formula of Rn? What is the formula for Rn? Is delta x times what? The sum of f of x I starting from 1 to infinity. Make sense? From I, like starting from like the first point, like f of x1, f of x2, f of x3, up to f of xn. Like if I wanna rewrite it, this one, delta x times f of x1 plus f of x2 plus dot 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 plus f of xn, like this. Make sense? Okay, my question is, what is delta x? So I need to find the value of this one. What is delta x? What is delta x? Is the first, is the end point minus the starting point over n. What is the end point here for this function? Here's my function. And here is the end point, starting point, and this is the end point. What is delta x? 2. Exactly, correct. It's 2 minus 0 over n is the same as 2 over n. Okay, now we need to find f of x1, f of x2, f of x3, up to f of xm. Make sense? So my question is, what is x1 here? What is this point, x1? So to know the value of x1 and x2 and x3 up to xn, I prefer, for my opinion, as you like, if you have different way to solve this question, would be okay. Draw a line like this, both the first point, both the last point, and like you have to start, like you have to start, like they have to divide this one as to the n sub-intervals like this. So such that the first point is the same as delta x. The first point is the same as delta x because this is delta x. All of them, they have the same width, like we said before. Make sense? So this point actually is what here? Is 2 over n. And this point here is the same as what? Is delta x plus delta x. What is delta x plus delta x? Is what? I need you to participate. What is delta x plus delta x?
4 over n.
What is 2? Exactly, it's 4 over n because 2 over n plus 2 over n is the same as 4 over n. So this point is 4 over n. And what is this point? Third point is 6 over n because it's the same as delta x plus delta x plus delta x. Make sense? If you don't want to like think like this, you can think of this point as the starting point 0 plus delta x. This point is the same as 0 plus 2 times delta x. This point is the same as the starting point is 0 plus 3 delta x, and so on for all points. Make sense? So I can define like x1 as the same as 0, like the starting point is called, I call it like x0 plus delta x. x2, the point, second point is x0, the starting point, plus 2 delta x. x3 is the same as the starting point, x0 plus 3 delta x, and so on. And so on for all points. Okay. Now, my goal is to find f of x1, means f of 2 over n. Second things, f of x2 is the same as f of 4 over 2, 4 over n, and so on. What is f of xn is the same as f of n over n is the same as f of 2. Like it's the same as, I'm sorry, it's the same as 2n over n, 2n over n. How I find it? Here's the formula. So delta x, like I'm gonna repeat all these things here and find the formula for r of n. So this is the same as delta x again is the same as delta x from the question is 2 over n. Here's 2 over n. And this is the same as f of the first point is 2 over n plus f of x2 is 4 over n plus dot 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 plus f of 2n over n. 2n over n. Okay, what is f of 2 over n? What is the function here? By the way, f of x, the function is what? E to the what? Minus x. This is my function. So you're gonna plug this value inside here, this value, all of them, you're gonna plug it inside this function. I'm gonna get 2 over n, e to the minus 2 over n, plus e to the minus 4 over n, plus dot dot dot, e to the minus 6 over n, plus, here's some points, plus e to the 2n, minus 2n over n, like this. This is r of n. Now I need to find the area. What is the area? What is the area? Is the limit when n goes to infinity. Is the same as the limit for n goes to infinity. For what? For 2 over n times what? Times the sum of e to the minus 2 over n plus e to the minus 4 over n plus e to the minus 6 over n plus dot 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 plus e to the minus 2n over n. Make sense? That's it. We don't have to find the limit because the question they said don't evaluate the limit. If you want to write it in the sum notation will be the limit of 2 over n times what? The sum of e. Here the change is only the numerator 2, 4, 6, 2n, but the denominator are the same. Do you see? So I can write it as minus 2i over n, such that I starting from which point? From 1 up to n. From I equal 1 up to n. Here n goes to infinity. This is the area. Any question? Any questions for the first part? Now the second part, we're gonna do it. Any question for the first part so far? No questions? What about the other student? No. What about the others? We have 33 students. Okay. So now the next one, estimate the area by taking the sample point as the midpoint. Okay. Estimating the area by taking the sample point as the midpoint. So, but they give me for 2 subinterval. The first one is for 4 subinterval and the second one for 10 subinterval. So I'm gonna do the 4th subinterval, and the second one is 10 subinterval is exercise for you, and you should do it. Why? Because you're gonna see it in the exam. You're gonna see it in the exam. So you should do it. You have to do it. Not just you should, you must do it. So I'm gonna do the second one, the second part, B, when n equal what? What is n here? Equal 4. N equal 4. So this is mean delta x equal what? What is delta x? When n equal 4, what is delta x for the same function? Is b minus a over n. What is b? What's b? Exactly 2. What is a? Zero over n. What is n? What's the answer? What is 2 over 4? Is 1/2. Correct. So delta x is 1/2. Now I have the interval look like this. Look the interval. Here's the interval. This is the starting point, 0, and the end point is what? Is 2. So I'm gonna divide this interval up to subinterval, up to 4 subintervals, up to 4 subintervals. So here's the subintervals. 2. Here's 4 subinterval. But I want to make it like more equal. Here's 4 subinterval. Okay. So this point I call it again x1, x2, x3, x4, and this point is x0. So what is x1? What's the value of x1? What is the value of x1?
1/2.
1/2, exactly, is the same as the starting point is x0 plus delta x is the same as 0 plus 1/2 is the same as 1/2. Okay, what's the second point? What is x2? x0 plus 2 delta x is the same as 0 plus 2 times 1 over 2 is the same as
1.
1. And the third point, x3, what is it? 3 delta x is the same 1/2 plus 1/2 plus 1/2 is the same as 3 over 2. 3 over 2. Okay, now they ask for the midpoint. What is the midpoint for this interval? It's here. And here's the midpoint. And here's the midpoint. And here's the midpoint. So this point I call it x1 star. This one x2 stars. x3 stars. x4 stars. Now, what's the midpoint here for the first one? 1/2 plus 0 over 2. What is it? So it'll be like 1/2 plus 0 over 2 is equal what? x1 star is the same as the midpoint is 1/2 plus 0 over 2 is the same as 1 over 4. Correct? Is it correct? So this point is 1 over 4. This is what I need. Now x2 stars, what is it? Is 1 plus 1/2 over 2. What is the point? 3 over 4. 3 over 4. Now, what is x3 stars? Is 3 over 2 plus 1 over 2. And the answer is what? What's the answer? What's the answer? It's 5 over 4. Okay. x4 stars is the same as 2 plus 3 over 2 over 2. And this is, where's the point here? Here's 5 over 4. 7 over 4. Correct. 7 over 4. Okay. Now I'm going to use this, the green points. I'm going to use this green points. to find the area. I'm gonna use these things here. Sorry. Use these things. Use these things. These things and this thing. Okay. Now, what's the area? The formula like this: M4 equal delta x times the f of the x1 star plus f of x2 stars plus f of x3 stars plus f of x4 stars. Okay, what is delta x as we found it before? What is delta x? It's 1 over 2. 1 over 2, we find it before. It's here. It's 1 over 2. Now, what is f of x1 stars? Is 1 over 4 plus f of 3 over 4 plus f of 5 over 4 plus f of 7 over 4. 7 over 4. Makes sense what I'm doing right now? Just a plug inside the. Yes, go ahead.
If it doesn't tell us to like find like the exact answer, can we just leave it like this?
Yes, you can leave it like this because the calculator is not allowed in the exam.
Okay.
But you can plug the values. So what is f of, what's the function f? What's f of x? What's the function f of x? In the example, e to the minus x. Just to plug the values. E to the minus 1 over 4 plus e to the minus 3 over 4 plus e to the minus 5 over 4 plus e to the minus 7 over 4. And this is the answer. Done. This is M4. This is the area by using the midpoint. And if you want to use the calculator to find this one, this is like close to 0.88557. Now, M10 is exercise. Okay. So you're gonna do it. Make sense? The same steps, same things, same ways. Any question? Any questions? No questions. Okay. So this section is done.
Yeah.
Yeah, go ahead.
So first we just have to find the delta x, right? And
Yes,
then we just have to find the point which is actually there, like the midpoint or the left hand point or the end point. And then we just plug it in. That's it.
Exactly. That's it. That's it.
Okay.
Yeah. So this section is done. So let me go now to the new section. This is 5.2. It's called the definite integral. So we after like this section is 5.2 is the definite integral. We're gonna talk about the integrals. Definite integrals means the integral is defined. They have a limit for the integral. So the definite integrals is the same as the area. What the mean of the same as the area is the same as the formula we use it is the same as these things. So by the way, we was like starting for this section talk about the area. So the area here is the same as the integral. So this is the integral, by the way. This things is the integral. Again, the area here is the same as the integral. All the area, the limit is the integral. This is the integral. Okay, so we was talking about the integral, but we wasn't know this is the integral. So the definite integral means the limit for r of n. or the limit for L of n, doesn't matter, when n goes to infinity. Okay, so I'm gonna like say starting for the new section here is 5.2. I mean, like no special, like something different here, like the same as the previous section, nothing like something new. I mean, 5.2 is called the definite integral. Okay, just review. You should know the limit, like as we learned before, of the sum of, I mean, like the by using the sample point, like the sum of the function f of xi stars times delta x, such that I start from 1 to infinity, when n goes to infinity, is the same as the limit. Here I can like said, I can take the delta x outside the limit. I can say it like it's the same as delta x times the limit of f of x1 stars plus f of x2 stars plus dot 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 up to f of xn stars, like this, when n goes to infinity. This is the same as the previous section. Okay. Now I'm gonna define the integral. So I can define definition of the definite integral here, definition. Of the definite integral. Oh, by the way, I'm gonna stay here up to 12 today. Makes sense? Like 20 minutes more than like usual, at up to 12 for today. Definition of the definite integral. Okay, so you should know, here's the sample, the symbol of the integral is look like this, like S from A to B for the function f of x. Del of x is the same as the limit. For what? For the sum of f of xi stars. This is called sample point, delta x. You know the sample point. Sometimes the sample point is a midpoint or any point inside the subinterval. Okay? I equal 1 to infinity. Here n equal goes to infinity. Again, this is a sample point. Sometimes it's the midpoint or any point inside the subinterval. Doesn't matter. So the integral defined like this, the limit of these things. But I'm gonna like define something like here. I'm gonna show you exactly what is that. Here f is the function, is a function defined for the interval a comma b. This is the first thing you should know. Also, you should know delta x is the same as b minus a over n. And n, what is n here? Is the number of the subinterval, of the subinterval, intervals. Okay, what else? You should know x0 is the same as a, is called the endpoint, is the and xn is the same as b, is the endpoint of the subintervals. is the endpoints of the, I mean, like, yeah, the endpoints only. It's not the sub for the subinterval, just the endpoints for the interval. I mean, the big interval. The sample points here: x0, x10 stars. I mean, x1 star, x2 stars, x3 stars, up to xn stars. All of them called sample points. Okay. Number 1, number 2, number 3, number 4. So what is the integral? What's the integral? Is the limit for what? The limit of what? Is the limit of the sum. What does that mean? Is the area. This is the same as what? Area. So what is the integral? Is area. Make sense? So what is the integral? Is the same as area. Area for what? Under the curve. The area under the curve. Under the curve. Make sense? So the limit is the integral is the same as the area under the curve. Okay. Okay. And this things here is called Riemann sum. So all of them is called Riemann. So we was finding Riemann sum in the previous section. So the integral is the same as Riemann sum is the same as the area. Okay? Is the same as Riemann sum is the same as the area under the curve. So the integral is the same as Riemann sum. If I ask you what's the Riemann sum, is the same as the sum or the limit. The limit. If I ask you what's the Riemann sum, is the same as the limit when delta the sum of f of xi stars times the delta x is the same as the integral. Okay, I give you example. Here's example. The question is evaluate the Riemann sum Riemann Riemann sum for the function f of x equal x to the power 3 minus 6x starting from the point 0 up to 3 with an equal 6 subintervals and take the sample endpoints to be right endpoints and take the sample endpoints to be the right endpoints. Again, the sample point sometimes is the midpoint, sometimes is the left point, sometimes is the right point, sometimes whatever. But here in this question, I told you the sample endpoint is the same as the right endpoint. Okay, so we're gonna do it together. This is same as the previous example, nothing new here, different new. So you should find actually the limit. So the goal here to find the limit for what? Delta x times f of xi stars when n goes to infinity. This is what they need. Okay, my question is, what is delta x? What's delta x?
1/2.
It's 1/2. How you find it?
3 minus 0 over 6.
Exactly. This is 1/2. Now, f of xi, here is the x point here, the xi here is the endpoint, is the right endpoint. So we're gonna like graph a
It's 1
smaller
over
line.
2.
Exactly. It's I mean like it's the right endpoint. So we're gonna graph a line like this. We're starting from 0 up to 3. And we have to find here six subintervals. Here is the middle point. 6 subintervals means we have to find 6 subintervals means we have to find like 6 subintervals means we have to divide this line up to 6 intervals. Okay, here is 0, here is 3. This is the midpoint. Here is okay. Yeah. So this is the first one. 1, 2, 3, 4, 5, 6.
It should be 1 over 2. You wrote 1
1,
1/3.
2, 3, 4, 5, 6. What you said?
It should be
1
1
over 2.
over 2.
Yeah, correct. Thanks. 1 over 2. So I divided to the 6 subintervals. Here's the first one. Here is the second one. Here's the third one. Fourth, fifth, sixth. Okay. So at this point here, we're gonna start like from the starting point. This is x1, this is x0, x2, x3, x4, x5, and here is x6. Okay. What is x1? 1/2. Y is the same as the starting point plus 1/2. Okay, what is x2? What is x2? 1/2 plus 1/2 is what? 1. What is x3? Is 1/2 plus 1/2 plus 1/2. Will be like 3 over 2. What is x4? Is 4 over 2. Will be like 2. What is x5? 5 over 2. What is x6? 3. Now they ask for f of xi as the right endpoint. So this is my right endpoint. Right endpoint. Why? Here's the first interval, second interval, third interval, fourth interval, fifth, and sixth. And I'm looking for this point. I'm looking for this point because this is the right endpoint. For this point, and this point, and this point. Okay, f of 1/2, my question here. Because this is my right endpoint, f of 1/2 here. I have to look for 1 f of 1/2, f of 1, f of 3 over 2, f of 2, f of 5 over 2, and f of 3. Okay, what is f of 1/2? I plug this value inside the function. Plug this value inside the function. What do you get? What do you get? I need your help. What's f of 1/2? After you plug it inside the function here, plug this one inside the function. Minus 2 point, I think 8. And the second one, f of 1. What is f of 1? It will be 1 minus 6. 1 minus 6 is what? Is minus 5. And this point is what? 5 point minus 5.6. And this point is what? F of 2 would be like 2 to the power 8. 2 to the power 8. I mean, 2 to the power 3 is 8. Minus 12. it will be 4, minus 4. And f of 5 over 2 is what? F of 5 over 2 will be like minus 6, 0.6263. And f of 3 is what? Be like 3 to the power 3 minus 18 is equal what? 9. Make sense? 9. Okay. So I find the values. Now just plug them inside the formula. So I'm gonna plug inside the formula. R of what here? R of 6 equal delta x f of 1/2 plus f of 1 plus f of 3 over 2 plus f of 2 plus f of 3 over 5 over 2 plus f of 3. Okay, I'm gonna plug the values. 1 over 2 minus 2 over 8 minus 5 over 0.6 minus 4 minus 0.625 or 6.3 plus 9. Okay, and after you finding in the calculator for this, the answer is minus 3.9375, and this is the Riemann sum or the integral. Okay, so this is the Riemann sum or the integral. Makes sense? By the way, here is the answer is minus. This is not representing the area, by the way, because I never say like the area is negative. But this is represent the integral. Okay, this is represent the integral, but does not represent the area. Why? Because the answer here is negative. Can you hear me? So we're gonna stop up to here for today. Next time I'm gonna give you like more examples to show you how we using the integral and Riemann sum for some examples. Any question?
For this one, we used it right-handed endpoint, right?
Here we use the right hand. We use the right tables, the right hand points. Yeah.
If we use the left-handed interval, you would have start from 0 to 5 over 2, right? Up to
If
5
we
over
start,
2.
yes, exactly. Start from the 0 for the left points. Correct.
We don't use the last point, right? Because it's talked about the left-handed.
No.
Okay.
Let me share like the screen here. Everything is clear. Let me share the screen. What screen? Okay, before we start here. Okay. Any question before we move? Before I end the class, any question?
No.
No questions? Okay, I see you next time.
Yeah, I
on
have a
Tuesday.
question.
Professor, can I speak to you?
When will you send the
Send what?
the like work for like the practice work for the test?
Yeah, I'm
and
gonna
quiz?
do it by tomorrow maximum. Like I'm gonna send it like earlier tomorrow.
Okay.
Okay, so you can
Right.
like starting for solving the question for the chapter 4 for the quiz. Get ready for the quiz and the exam too.
How
And
many questions on the quiz?
The quiz like 1 question or 2 questions, maximum 2 questions. The maximum is 2 questions.
Wait,
Okay.
so Professor, in case the school does not open up, we are going to take the quiz online?
Which one? If it's not opening, I'm gonna like do it online or in the Blackboard. Yes, I'm gonna send it in the
Okay.
Blackboard. Yeah, I'm trying to do
So
it in
it's on Tuesday, right? Like the quiz.
Tuesday.
Yes, correct.
Thank you.
Yeah, so here is I get the question. I square is n times n plus 2 plus times 2n plus 1 over 6 I square. What is the I square here? What do you mean for I square? Okay, I'm gonna end the class for recording, and I will see what's your questions.